Bismillahirrahmanirrahim. Today I'd like to talk about indirect proofs. There are many different types of proofs. The proofs that we've been doing, the two-column proofs, are called direct proofs. To appreciate the difference between a direct and an indirect proof, I thought I'd start off with an example. So here's an example question which we'll do initially with a direct proof. We're given that AC is congruent to EC. Here it is. And we're also given that BC is congruent to DC, which is over here. And then we are asked to prove the triangle ABC, which is this one over here, is congruent to triangle EDC, which is this one over here. Well, that seems reasonable enough. I think I could do it. Well, these two angles are vertical angles, and I know that vertical angles are congruent. Then I can say, oh, look, I have side angle side, side angle side, and voila, we have it. We have the two triangles congruent. So this would be an example of a direct proof. In a direct proof, you take the given information and you take it through your logical reasoning using definitions, postulates, axioms, theorems, etc., and come to the desired conclusion. And that's what we did over here. We started with the given information and we brought some of our own insights, and then we proved the triangles to be congruent. Now, indirect proofs are different. I think the most important aspect of understanding indirect proofs is their beginning. The critical difference between a direct and an indirect proof is how they begin. Now, indirect proofs, instead of starting with the given information, they start with what we're trying to prove. And then they say, assume that that is actually false. So indirect proofs start like this. Assume temporarily. Assume temporarily. Assume temporarily that the very thing that you're trying to prove is in fact false. And then what you do with that is you run with it. You extrapolate from that assumption until you reach a contradiction. And then you would be done. Now, if you're like me, you're probably thinking, this sounds like making things harder than they need to be. Well, not really, actually. It depends on the proof. It depends on the question. It depends on the problem you're trying to solve. In fact, in real life, we use indirect proofs all the time. For example, Dad might say, son, did you eat the cookies? And the son might say, Dad, I did not eat the cookies. Now, assume for a second that I did eat the cookies, Dad. If I ate the cookies, would I not have like crumbs in my pockets and my mouth? Now look, you see any crumbs? No, and there are no crumbs in my room. Therefore, I did not eat the cookies. So indirect proofs start out with the assumption that the very thing that you're trying to prove is in fact false. Now consider this example. The question says, prove that if 2x plus 3 does not equal 7, then x does not equal to 7. If we were to do this using an indirect proof, the first thing that we would say is we would negate this statement right there. We would say, assume temporarily what? The opposite of the statement, that x equals to 7. Now, we are told that 2x plus 3 cannot equal to 17. Well, if x was 7, then you would have 2 times 7 plus 3 does not equal to 17. Let's see what would happen if you substitute 7 in place of x. Okay, that's 14 plus 3, and our statement says it should not equal to 17. 14 plus 3 is 17. Does 17 does not equal 17? No, this is a false statement. 17 equals 17. Since 17 equals 17 and we have reached a contradiction or a false statement, then our original assumption right here must be false. Since this is a false statement, our original assumption, that is x equals to 7, is false. Therefore, x does not equal to 7, and that is what we were trying to prove. So that's how you do indirect proofs. They always start with, or similar to like this, assume temporarily that the very thing you want to prove is actually false, and you assume the opposite is true, and you start from there. So here's some examples that I found. It says, write the first sentence of an indirect proof of each conditional shown, of each statement shown. If AB equals BC, then triangle ABC is not scaling. Okay? First statement of the indirect proof would be, assume temporarily that that what? That triangle ABC is scaling. Triangle ABC is scaling. That would be the first statement. And the second example, if n squared is greater than 6n, then n does not equal to 4. Now we would start this proof as assume temporarily that n equals to 4. Now the third one says if the measure of angle 1 equals measure of angle 2, then the segment XY is parallel to segment CD. The first statement here would be assume temporarily, in my terrible handwriting, assume temporarily that XY is not parallel to CD like this. That's how you would start those proofs. Okay, I'd like to finish off with this example. Given P is not the midpoint of HK. So here's H and here's K, and we're told that P here is not the midpoint of it. Alright, I don't quite know how to use that information, but I'm just going to keep that in the back of my mind. Now we are told that HJ, which is over here, is congruent to JK over here, like this. Then we are asked to prove that JP does not bisect angle HJK. JP, which is over here, this segment over here, we are asked to prove that it does not bisect this angle right here, that it does not bisect this angle right there. We're going to assume the opposite of the very thing that we're going to try to prove. So we're going to say, assume temporarily that JP bisects angle HJK. So we're going to say, assume temporarily that JP bisects angle HJK. So then we're going to say, okay, where am I going with this? Well, if that bisects it, then angle HJP must be congruent to angle KJP. Right here, those two angles must be congruent. That's the definition of angle bisector, right? Definition of angle bisector. So I'm going to write this as a paragraph proof. Well, where do we go from there? Well, I see some triangles. I'm going to use this as a reflexive property here. Then I'm going to say, now JP is congruent to itself. And I can say, see, these two triangles are congruent over here. Triangle HJP is congruent to triangle KJP. Now, they don't look like it, but that's the point. We're proving that those two triangles are congruent because of side, angle, side, right? Because I have a side, reflexive property, angle, and side on both sides. Okay? So those two triangles are congruent. Now, if those two triangles are congruent, then HP is congruent to P, like this. Because of corresponding parts of congruent triangles are congruent like this, CP, CTC. So now I have this is congruent to this. But that implies that P is the midpoint of HK. Now, that's from the definition of midpoint, correct? Because a midpoint divides a segment into two congruent segments. We're told that P is not the midpoint of this segment. Since this contradicts the given information, our original assumption is false. The original assumption being that JP bisects that angle over there. Therefore, P does not bisect angle HJK, which is what we were trying to prove. And that's how you do indirect proofs. You do indirect proofs is that you assume the opposite of what you're trying to prove until you reach a contradiction or a statement that is false. Once you reach that, then you realize that the original assumption must be false, and by default, that which you're trying to prove, therefore, must be true. This is indirect proof, and I think it's lots of fun. Until next time, as-salatu was-salamu ala rasulillah walhamdulillahi rabbil alameen. Assalamu alaikum.